So, in the last session, we have completed, right, what are related entities and how to load them using three different approaches. We have discussed what is eager loading, what is lazy loading, as well as we have also discussed what is explicit loading and right how to use them in our entity framework core applications. Today, what we are going to discuss, first of all, I will show you what is the default convention that is entity framework core follow to create the table, to create the columns names, to create the right data types, to apply the constraints, to establish the relationship, right? To create the primary key, foreign key, right? Indexes, right? How the entity framework is going to follow, right? How the entity framework is going to create those things, right? And what is the default approach that what entity framework for follow? Then we will see, right, how you can overcome these default conventions using data annotation as well as using Fluent API. So first of all, we will see what is the default convention, what entity framework follow to map our entities to database table. Then I will show you how we can overcome these default conventions, right, using two different approaches. One is using data annotation, and the second one is using Fluent API configuration. So let us first start, right? What is the default convention, right? So entity framework core, right? Default convention means what? Means some predefined rules are provided by entity framework core. And if you are not right, if you are not providing any explicit configurations, right, then this predefined rules, default predefined rules are coming into picture to map the right entity classes to the database tables, right? So what is this default conventions or what is this convention over configuration approach provides, let us try to understand. So automatically, right, guys, remember, automatically it is going to establish the primary key and foreign key properties based on the naming conventions, right? So based on the naming conventions, right, between the entities, automatically he is going to generate the primary key and the foreign key. Also, based on the application properties, right, between the entities, he is also going to manage the entity framework core, also going to manage the one to one, one to many, and many to many relationship between the entities. It is also deciding what should be the column data type, right? What should be the column data type based on the .NET data type. So if I'm using string, then what should be the data type? If I'm using a date time, right, what should be the data type in the database, right? So what is the default data types, right? How it is converting our .NET data types into, right, SQL Server or any specific database data type. That is what is going to be determined by the entity framework by default. Determining the table and column names based on the default convention means what? What should be the table name? What should be the column name, right? What is the default convention? Based on the default conventions, right? How it is determining what should be the table name, what should be the column name. That is what also we are going to discuss. Configure columns as nullable and non-nullable means what? Right? Means if I'm creating a property as a nullable type, then how it is right? How that property is going to be handled in the database? If a property is non-nullable type, right? Means what? Then how that non-nullable property is going to be handled by the .NET data, right? By the SQL Server or any database data type. That is what it is going to manage automatically, right? I will show you. So whatever I'm showing, I'm also going to show you this thing practically. At that time, I will show you what is default convention, what it is following. Also, right, also the framework, right, entity framework or also generate the indexes and constants, right? So it is also going to generate some kind of indexes and constant. For example, if a primary key is used, then it is going to generate a clustered index. For non-primary key, I mean for a unique key, right, it is going to generate non-clustered index by default. Means if you are creating any primary key column, then one clustered index is going to be generated, and for non-primary key column, or you can say for foreign key column, it is going to generate a non-clustered index. And also automatically set up the default cascade behavior. Right. So for example, if we are managing the relationship, there is something called right, the primary key and the foreign key. And if I'm deleting the primary key entry, then how the related foreign key entries are going to be managed? Whether I need to delete them also, or whether I need to set them with some default value, or whether I need to restrict the primary key to be right, deleted. So that default behavior is also going to be managed by the entity framework code, right? So What I'm going to do is first I'm going to show you all these things, right, using one example, and then, right, and then as you progress, right, I'm going to show you one by one how you can overcome this default conventions what entity framework or follow using two different approaches, starting with data annotation, completed with the right Fluent API configurations. Clear, guys?
Yes, sir.
Now, let us try to understand the default convention with one real-time example. So basically, what I'm going to do is I'm going to create the right four entities. One you can say student, teacher, course address, and one enumeration, right? So this enumeration is going to be used within the right student and the teacher entity to specify the gender of the student as well as the gender of the teacher. So using these entities, I'm going to discuss right what is the default convention or default configuration, right, followed by entity framework code to generate the database table names, database table columns, primary keys, foreign keys, indexes, what should be the columns data type, what are the different kind of indexes, what are the different right kind of a constants like nullable constant, null constant, not null constant, right, identity, how it is going to manage the relationship between different right between the database table, one to many, many to many, as well as right how the default cascade behavior is implemented by entity framework code. So we are going to discuss all these things by taking one example. So let us proceed and review the entities first. We are going to work with the same example, right? So within this example, okay, let me first remove this code, whatever is already there. So same, right? As within the same application, I'm going to develop the application. So first of all, what I'm going to do is whichever entities are not required, let me first delete those. What are the entities required? Student, teacher, course, and address. So address is required, branch is not required. Let me delete that entity. Course is required, student is required, subject is not required. Let me delete that entity. Right. So let me first right create these entities. So student.cs. So to give you an idea about different data types, right? So what I have done here, I have created the student entity with different data types. You can see some of the properties as integer, string, nullable date time, decimal, boolean, byte array, gender, right? Complex type. So this is going to be an enum. This is a complex type, right? What or you can say reference navigation property, and this is a right what I can say collection application property. So basically here what I'm showing, I'm creating one entity using a different .NET data type, and then I will show you right how this .NET data type are mapped with right SQL Server data type, right? So that is what we are going to discuss. So this is my student entity. Next, what I'm going to show you is, right, okay, so in this case, guys, remember the student ID, it is going to be the primary key by default. I will show you, right, what is the default convention for the primary key, foreign key, all these things I'm going to show you practically. Let me first create the entities. So then the second entity is going to be teacher entity. So teacher ID, full name, hard rate, working hour, salary, and here it is having, right, one teacher can teach multiple courses, one to many relationship. Next one is the course entity. So the course entity, you can say this is having the course ID, title, credits, right? Credits means what is the total mark, teacher, and here you can say teacher ID, it is going to be the foreign key. That means whoever the teacher going to teach this course, that the teacher ID we are storing here. And this is I collection of students, right? One to many relationship, right? So here, if you want, right, if you want this course is going to be taught by multiple teacher, then what kind of a relationship you can define? You can define a I collection of a teacher. But let assume this course, one course is means is going to be taught by a single teacher. So for that purpose, I am implementing this one. But if a single course is going to be taught by multiple teacher, then what type of navigation property you need to define here? Collection navigation property. But for this example, right, for the demonstration purpose, let assume right one course is going to be taught by one teacher. The last entity what we are going to right, define is the address entity. So let me go to the address. So these are the address street city code, and intentionally I have provided this address ID inside this entity, right? Address ID, city, state, country, student ID. So here you can see teacher ID, and this is going to be my teacher ID foreign key, student ID foreign key. And here, most importantly, this is a optional relationship, right? So I'm putting a question mark means it is going to be optional relationship. Next, what I need to do is I need to create the gender enum. Let me go ahead and create the enum. So guys, remember, once I create the right database based on this models and DB context, then I'm going to discuss, right, everything. Everything means how the table is created, how the right columns are created, how the column data type is decided, how the primary key foreign key are established, right? Everything I'm going to discuss. So this is the gender enum, which is going to represent the different male, female, and other, and this gender is going to be used by the student entity. Here you can see the gender is specified. Next one is EFDB core context class. So guys, remember, I'm not implementing that log to, right? Why? Because I'm not interested for right showing the generated SQL. Rather than here, we are managing the database schema. So here you can see student, teacher, courses, and addresses. I have specified the DB set of a T properties, right? And in this case, it is going to create a database with the name my student DB. Let me first go ahead and delete this one, which I have created for my R&D, and that's it. So we have deleted that student, my student DB. Clear, guys? So this
Yes,
is
sir.
now what we have done so far. We have not discussed, right, how the database is managed. Rather than we have only created the entities and the DB context to manage the entities in the database. So once this is done, right, let me go ahead and remove this migration folder, and right, and one more thing that what I need to make sure, right, your right, this is program class is empty. That is fine. So now build the project and make sure your application is successfully building. Okay, completed successfully. Now what I need to do is I need to generate the migration file. So to generate the migration file, you can give any name, MIG1. So here I'm going to get some kind of a warning. Okay. So let us first understand what is this warning. So one warning and two warning are there actually. Let me open this. Right. So if you see it is saying no store type was specified for the decimal property GPA, and the same is specified for the decimal property salary. So what exactly it means? It means if you go to the student entity, you will see there are some decimal properties. One is decimal GPA, and if you go to the teacher, there is also a decimal property salary. So what exactly it means? It means it is saying that if you do not specify what should be the decimal value, right? I mean, what should be the precision after the decimal point, then by default entity framework core is going to create the data type with decimal 18 comma 2. But for example, if I'm going to store some value, something like 123.4567, then in that case, this value is silently truncated. It is going to store 123. So there is a chance that you are going to lose some data. So if you are interested with this decimal point 18 comma 2, then no issue. But after the decimal point, if you are storing more than two values, right, then those values are going to be silently truncated. So in our coming sessions, right, I will show you how you can overcome this problem. So basically what you need to do, you need to use some kind of column attribute, right? So let me show you. Right, so we need to use some kind of a column attribute, and using this column attribute, so what I can do is I can specify. So this column attribute, again, it is present in a different namespace. So I'm not showing this that one. I will show you. So here, what you need to do, you have to use type name, right? And here you need to specify, right, a decimal comma 18 comma 4 or something like this. A decimal comma 18 comma 4 if you want to accept four decimal point after the right four precision value after the decimal point. So you have to write something like this. This column attribute, it is present in a different namespace. This is the data annotation attribute we will discuss. But for now, just right, ignore this warning, and we are happy to store, right, two decimal point value after the right decimal point. So once this is done, right, then what I need to do, I need to update the database. You guys understand why I'm getting this warning?
Yes, sir.
right? So after the decimal point, right, by default it is going to accept two right values, and that is the reason why it is giving you that warning. If you specify more values, then they are going to be slightly truncated, right? So once the migration file is generated, update the database. So again, the same value, same error you are getting, that is fine. You can ignore. So at this point of time, your database should be created. So you can see my student DB database is created, right? So that's fine. Okay. Now let us try to understand what are the default entity core configuration schema, right? So first of all, we need to understand what is the default schema. Guys, remember, if you are creating a table in SQL Server database, what is the default schema?
DBO.
DBO. DBO is the default schema for SQL Server database. So the point that what you need to remember while creating the database, if we do not specify what should be the default schema, then by default, Entity Framework Core is going to use the default schema respect to the database provider. For example, if I'm using SQL Server database, the default schema is going to be DBO. Similarly, if you are using MySQL Oracle, then what is the default schema respect to that particular database? That schema will be used by Entity Framework Core. Now, as I'm targeting, I'm using, right, what I can say, SQL Server database, so default schema is going to be DBO. Now, if you verify the my student DB, then you will see all these tables are created with the default schema DBO or not?
Yes,
Yes
sir.
or no? So
Yes.
what is the default schema? The default schema is DBO. Sir, can we create different schema? I want to create some of the table with admin schema. I want to create some of the table with sales schema. Is that possible? Yes, that is possible. How? That is not possible with the default convention. Default convention means default schema will come into the picture. If that is your requirement, then you need to go with the data annotation or Fluent API configuration. And that is what we are going to discuss, right? So we will discuss once this default convention completed. We'll start data annotation. At that time, I'll show you right how to create a right custom right what I can say schema. But now it is fine. Default schema for SQL Server database is DBO, and that is what also Entity Framework or follow when creating the tables. Clear, guys?
Yes, sir.
Right. So what is the default table name? Right. So default table name. What is? So guys, remember the default table name is going to be entity name. Entity name. Else, it can be the DB set property name. Property name. DB set dot property name. So in this case, right, as you can see, in this case, as you can see, right, for example, if I'm creating a teacher table, then by default it is going to be teacher if it is not specified in the DB set of a T property. If I'm specifying DB set of a T property, then whatever the property name I'm providing, that is going to be the table name. Whatever
By
property name
default, it
I'm
is taking entity name.
sorry, sorry, can you please
Like,
repeat?
by default, it will take entity name.
Your
Like
voice, your voice, your
teacher without S.
so your voice
I
is
mean,
not clearly
by
audible to
default,
me. Your
okay,
voice is
fine.
not clear, guys. Is his voice clearly audible to you guys?
No, sir.
No,
No, sir.
sir. It is not
Your
clear.
voice is not clearly audible. So, guys, remember for
He's
this.
trying to say that he's
Yeah.
trying to
So,
say that by default it will take entity name. He's
so that is
asking.
what I'm going to explain. When it will take entity name and when it will take a dbset dot property name. That is what I'm going to make you understand, right? For example, right? This is my student entity, right? So here, what I'm going to do, I'm going to create another class file, public class, right? What I can say, extra activity, extra activity, right? So in this case, what I'm going to do, public ID, right? Extra activity ID. Then here what I'm going to do, public string, right? Activity name, right? Activity name. And here what I'm going to do, public integer student ID, public. Then here what I'm doing, student, right? And here what I'm doing, so what extracurricular activity the student is doing, that reference property I'm providing here. So public, right? What I can say, I collection of extra activities. Clear? So that is what I have specified here. So now let me run the application and see what will happen. So basically what I have done, okay, let me make this as a simple entity, extra activity. Right? So what I have done, I have added one entity here, and that entity I referred from the student entity, right? And here I'm creating this one. But what is currently I'm doing, and if you look at this entity DB context class, I'm not going to specify that extra activity as a DB set property. Currently, I'm not specifying. Okay. So now what I'm going to do, I'm deleting this one and deleting the my student DB database, right? And okay, let me generate the right migration one more time. Right now verify the database table. Hare Krishna, who is Hare Krishna? Why did you doing all this thing in the screen? Teachable data annotation for all. I say I don't know why you guys are doing these things. Okay. Now let's check the my students. Not this one. Yes, this one. So in this case, this extra activity it is also created as a table or not?
Yes.
What is
Yes,
the
sir.
table name?
Extra activity.
So the
DBO
table name,
dot.
the table
Entity
name,
name.
the table name is nothing but the entity name or not?
Yeah.
Yes, sir.
But coming to student entity, what is the table name here? Students. Why? Because we have specified that as a DB set property. So the point that what you need to remember, if we are specifying something as a DB set property, then that is going to be the table name. If I'm using one entity which is referred by these entities, right, then also it is going to create a table. But in that case, the name is going to be your entity name. For example, in this case, extra activity. This extra activity I'm using as a reference property in my student entity. So this is the reason why, as this is a complex type property, automatically framework is going to create a table to handle this extra activity, and that is nothing but your extra. And in this case, whatever your entity name, that is going to be your table name. And if I'm specifying, right? For example, if I specify this inside my extra activity, for example, now what I'm doing here, I'm specifying extra activity here. If I specify extra activity and here, if I say this is, then now what should be the table name? If I
Extra
generate
Extra
my
activity.
table name,
activities.
the table name is going to be this one. So the point that what you need to remember, there are two types. One is the default entity name. If it is not refer by the DB set property in the context class, and other one is a DB set dot property name, which is going to take the priority. Clear?
Yes, sir.
Right? So this is how the default table name is configured. Right? If
Sir,
we are
will it replace if we can run configure migration again? Will it replace with the new name or what happened?
So already this table is created, right? So okay, let me generate this one. So see, table name you cannot change. Put the things you can add it. If the table is already generated, right? You cannot. Okay, let me give a different name, right? So now you can see. Let me replace this
Two
one.
tables.
Clear,
Okay, sir.
right? So we understand two things. One is what is the default schema and how the entity frame are configured the table name. Is that clear?
Sir, here I have one doubt, sir. So, for example, if the table contains any data, then in that case, what will happen?
Data will be there. Data will not be deleted. It is the
Okay, just
responsibility of migration to keep data. If some data is
okay,
going to be deleted, it will give you that information in the warning. Yeah, you are going to lose some data. That warning you
okay,
will get, right? Otherwise, if
okay.
no
For
warning,
example, okay, that is fine. For example, I have 10 columns, and 10 columns have the table have 100 records, and I'm going to add one more property to the existing entity. In that case, and that entity, I'm going to set it as not null. So, in that case, will it
so you
allow
can do
to?
that. So you just tell me, already table is created and already
Okay,
100 records are there. How you can create a column with not null constraint?
okay,
So what you need to do, you need to create that as a nullable column, store some data, then again make that null.
okay. If it is nullable and if we can write the migration, that will accept, right?
And then once you create the column, whatever the default value you want to store, you just put it inside that column and then make that column as a null. Clear?
Okay. Yeah.
So next
And
what we
sir,
need to,
if
yes.
one more thing, if it is we did not provide any primary key, the unique ID it is taking it as a primary one, right? But
When
if we
you are
wanted
thinking
to,
about, right, so you just tell me, am I discuss anything how the primary key is going to be created? So if I'm
Mhm.
going to discuss the primary key next, why you were asking the question
Okay,
earlier,
okay,
right? Okay. So now coming to the primary key, right? What exactly entity framework is going to do? It will look for the primary key is right, by default, it will look for a column with the name ID or whatever your entity name plus ID. It will look for a default, right? The default primary key column name is going to be ID or entity name plus ID. For example, in this case, what is my entity name? Entity name is student. Is there any column with the name ID or student ID?
Yes, sir.
Yes.
Student plus ID.
Student ID means it is going to be the primary key. So teacher ID. So entity name dot ID. Course, right? Course and course ID. Address, you can say address ID. So in this case, right, yeah, we are using entity name plus ID. Instead of entity name plus ID, can I use a teacher ID? Yes, that is also possible. So if I'm using this ID, then this is going to be my primary key. Clear?
yes, sir.
Yes, sir.
Right. Now, if you look at the table, right, then by default you can see this column address ID is my primary key. This is courses, it is going to be my primary key, right? Course ID. Then this is going to be my extracurricular activity. Here you can see which one is the primary key.
ID.
ID.
And why? Because in this case, right, by default it is looking, right? By default it is looking for a column which is going to be ID or entity name plus ID. If anyone is available, then that is going to be the primary key. Clear? Now, you might
Yes, sir.
have one question. Sir, if both are present, then which one will take the priority? In that case, ID is going to take the precedence. So ID will become the primary key. Clear?
Yes, sir.
Now, you might have one question, sir. Is it possible to create a table without primary key? Yes, that is possible, but not with the default convention. If you are following the default convention, it is mandatory to have the primary key column. So currently we have not discussed about data annotation. We have not discussed about fluent API validation. Yes, right. What I can tell, if you want to create a table without primary key, that is possible. For that purpose, we need to use some kind of a fluent API configuration. But with the default convention, no primary key means it will not allow you to create the table. Clear, guys?
Yes, sir.
So
So
I
that
have
is
one
what.
question. I have one question on the entities. So when it is creating the entities, if you are not specified on the DB set as well, so does it create entities for the sealed class or for private
See,
classes which has
in
private
this
access?
case, so it doesn't matter whether this is a sealed class or whatever class, right? That doesn't matter. So what is matter? So in this case, right, if I'm specifying this address, all these are going to be created as a division property. Now, for example, I remove this one. I remove this extra activities from here. Then what exactly it is going to check? This is my entity and this is my reference entities. So this reference entities, whatever I have specified here, they are also going to be created as a database table. For example, I comment this one. So if I comment this one, now if I run the application, it is not going to create a table for extra activity. Why? Because this extra activity I have not specified in the DB set properties in the within the DB context class, and this reference entity is no longer referred by any entities which we are creating as a table in the database. Clear?
Okay, so access specifier doesn't restrict it from creating the table.
See, whatever access specifier you are talking about, what access specifier? Sealed class
Like
and something like this. So why are thinking
uh,
so much right from the day one? We are having some kind of right a TPT, TPS, right? Type or a hierarchy, type or concrete, right? All these things we are going to discuss. We are why you are thinking so much about the advanced concept that is already there in our syllabus. And as we progress, we are going to discuss. Currently, what we are discussing, please focus on those concepts. Don't think about the concept which we are going to discuss in our coming session. So I have already
o-
provided the syllabus where I'm going to discuss right every concept whatever I have provided in the syllabus. Right. So please ask the question whatever I'm discussing. Don't ask anything which is supposed to be discussed right after 5 or 7 sessions.
okay.
Yeah. So now it's not clear why. Right? Now, if I comment this statement and if I do not specify this as a DB set property in my DB context class, then for now, this extra activity will not be created as a database table. Why? Because it is not referenced from either of any of the entities or which we are creating database table, as well as we have not specified this as a DB set property in the DB context class. Clear, guys?
Yes.
Yes, sir. And what is the default primary key name? The by default it will look for ID or entity name plus ID. If both are present, this will take the priority. If any of this is absent, then entity framework core is going to give you one error, right? While creating the migration, that no key is specified for this entity. Clear, guys?
Yes, sir.
So now next what we need to discuss, right? We need to discuss the foreign key, right? So single foreign key and the composite foreign keys, right? There are two types of foreign key. Let us try to understand. So single foreign key or one to right? In this case, what will happen? Now, in this case, by default, right, a foreign key name will be your relative entity name plus ID. So by default, the foreign key name is going to be your related name, entity name plus ID. So whatever your related entity name plus ID is going to be the foreign key. Right? For example, if you look at the student entity, so we are not creating any foreign key in the student entity. Coming to this teacher, we are also not creating. Coming to this address. So inside this address table, you can consider this is a foreign key. Why? Entity name plus ID we have to specify. So what is the default foreign key? Related entity name plus ID. So is this the related entity name plus ID? Student is the related entity. Yes, this is my related entity plus ID. So that means this is going to be the foreign key. So teacher is the related entity. So teacher ID. So this is going to be my foreign key. So by default, the foreign key column is going to be related entity name plus ID. Is that clear?
Yes, sir.
right? So this is in one-to-one. Now, if you look at the addresses table, you can see student ID, it is created as a foreign key. Teacher ID it is also created as a foreign key. And in the courses entity, you can see teacher ID is also created as a foreign key. Now, if you look at this teacher ID, this is teacher related entity plus ID. So the default convention what entity framework will follow is your related entity name plus ID is going to be the default foreign key. Clear, guys?
Yes, sir.
Now, this is right. What I can say, single foreign key. Now, what about the right the composite foreign key? So what about the composite foreign key? So the composite foreign key means what? Means the foreign key is the combination of more than one column. Now, if you look at the relationship between right student and courses, in the students table we are having this courses navigation property, and in the courses table we are having this student collection navigation property. So now, what type of a relationship is there between student and courses? Many to many. One student can enroll multiple courses and one courses can enroll multiple students. And how entity framework manage many to many relationship? By creating a joining table, right? And that joining table is nothing but the combination of these two entity names. And in this case, you can see the joining table is nothing but my course student table. So whenever we are creating the composite foreign key, I mean what to manage the right. So this is what I'm example I'm giving. You can also create composite foreign key anyway, which is the combination of two right keys. So in this case, the composite column name and key name is going to be table name plus primary key. So table name plus primary key. So table name plus primary key. So for example, whatever your first table, whatever the primary key, that is going to be the composite key. Now, in this case, this is student courses table, right? So this student courses table, it is going to, it is right, join. So this course students table, it is the combination of these two tables. So students table and the courses table. So what is the table name in this case? Students. What is the primary key? Student ID. What is the table name? Courses. What is the primary key? Course ID. Now, if you look at this, so what is the table name? Courses table, course ID. This is going to be my foreign key. Similarly, students table, student ID. This is also going to be my foreign key. Clear, guys?
Yes, sir.
Right? So if it is a single relationship, related entity name ID, that is going to be your foreign key. If it is a composite, then in that case, whatever your table name and inside that table, whatever your column name, primary key column, so that combination is going to be your foreign key. Is that clear?
Yes, sir.
Okay. Now, default constant. So default constant means what, right? In entity framework, right? Several types of constraints are automatically generated when we are creating the tables, right? So, for example, different types of constraint means you might be know something called primary key constraint, something called foreign key constraints, right? Something called a unique constraint, right? So these are the different kind of a constraint that what entity framework code uses by default. We can overcome the or we can customize this constraint right using fluent API and data annotation, right, which we will discuss right in our coming session. But by default, right, for primary key, it is going to create the primary key constant, and that constant name is going to be pk underscore table name. So what is the default primary key constant, that name is going to be pk underscore table name, right? For example, in this case, which one is the primary key? Course. I said, what is the table name? Courses. And in this case, right, if you open this one, then it is going to create the primary key constant. So why it is not opening? Okay. Yes, so here you can see that the primary key constant, it is created using pk underscore student, right? So that a constant means you see if it is a primary key foreign key, they are going to be created inside the keys folder, right? Some other constant, if we applied explicitly, they are going to be created here. Currently, we have not applied any kind of a check constant, right? A range constant. So these are now, if we apply, they are going to be created here. Now you can see on the primary key column, right? This is my primary key column. So what is the constant? The constant is going to be pk underscore your table name. So what is the default constant, right? Primary key column constant. The default primary key column constant is going to be, right, your, what I can say, pk underscore table name. So whatever your table name, it is going to create the constant with that name, which is specified by the prefix is pk underscore, right? So now, if you look at all the tables, right, to whichever which contains the primary key, almost all the tables are going to be contains the primary key. Why? Because without primary key, we cannot create any table. pk underscore courses. Now, if you look at the students, then it should show me pk underscore students, right? So what is the default primary key constant? That is going to be pk underscore your table name. Clear? Clear or not?
Yes, sir.
And what is the default foreign key constant, right? That what if you look at this, the syntax is this one. So fk underscore, this is the suffix, sorry, prefix. Whatever your dependent table, that means on which table you are creating this constant. And this is the right primary key table name, and whatever the foreign key column, that what you need to specify now. So whichever table so contains the foreign keys, let me start with this, right courses entity. So this courses entity contains one foreign key. This is my foreign key teacher ID, so courses entity. So according to this syntax, right? So according to this syntax, tell me, right, what should be the foreign key name? So it should start with the fk underscore, whatever your dependent table name. So in this case, my table name is courses. Yes or no? And whatever
Yes.
your right principal table and this teacher ID pointing to which table?
Teachers,
It is pointing to
Yes.
teacher.
teachers table. And whatever your foreign key column name. So what is the foreign key column name in this case? Teacher ID. So this should be the foreign key constant. Now to verify this thing, open this one. fk underscore courses underscore teachers underscore teacher ID. Yes. This is how the default foreign keys are going to be created. Clear, guys? Yes or no? Clear? What is the
Yes,
default
sir. Yeah.
constant? Right. So in our example, we have not applied any unique constants. Right. If we apply the unique constant, right, then they are going to be created with the name ak underscore whatever your table name and the column name. For example, if I'm having one user entity and where we are storing some email address, and we want to make sure that email is going to be unique throughout the database, right? Then what we need to do, we need to apply unique constant on that email column. So once we apply the unique constant, let assume the student entity is there. So it is going to be, right, your student's table name. So ak underscore students hyphen, right, ak underscore student underscore email. So this is how it is going to create. And by default, right, there is no unique key constant is configured. For that purpose, right, we need to go either with data annotations or we can go with, right, Fluent API validations, which we will discuss, right, in our coming sessions. So, but by default, right, there is no unique constant is applicable, right, while creating the table. Clear, guys? Okay. Right. So we'll, right. So whatever I'm saying, so this is not possible by default, but it is possible using, right, what I can say, uh, with the Fluent API or using data annotation. So next one is going to be indexes, and there are two types of indexes. If you guys know, there are two types of indexes. One is clustered index, another one is non-clustered index, right? So if you are creating a, right, if you are creating a primary key column, then for the primary key column, it is going to create a clustered index. For primary key, it is going to create a cluster index. For non-primary key, or you can say foreign key, it is going to create a non-clustered index, right? So this is the default behavior what entity framework or follow. If I am having any primary key, it is going to be created a clustered index. For a foreign key, it is going to create a non-clustered index. Maximum one clustered index per table. And the foreign key, right, or non-clustered index, you can create as many number as you want. And this is the default convention. But apart from this, right, any other column is there which is not a primary key, not a foreign key, but on that column you want to create some kind of indexes. Is that possible? Yes, that is also possible. How we can do this? For that purpose, we need to use data annotation and Fluent API configuration. But this is the default behavior, right? So what is the default foreign key, right? Default index name. So default index name is going to be, right, whatever your primary key, right? So that pk underscore table name, this is going to be your default index. And for foreign key, right, the default name is going to be ix underscore table name underscore foreign key column name. So this is going to be my default index, right? So for clustered index, it is going to be pk underscore your table name. Why? Because maximum one cluster index you can create. So no need to specify any column attribute. For foreign key indexes, right, non-cluster index, you can create any number, right? So a table can contain more than one foreign key. Then for each foreign key, it is going to create a index. So to specify that purpose, right, to specify that ix, it represent non-clustered index, whatever your table name underscore your column name. For example, if you look at this address entity, so if you look at this address entity, you can see there are two foreign key. One is student ID, another one is teacher ID, and one is primary key address ID. So how many indexes should be there? So for this address table, if you understand this concept, tell me how many indexes should be there?
Three.
Three.
Three. One is
Three.
cluster index. One is cluster index, which is going to be created based on the primary key. That name is going to be, what should be that name? Name is going to be pk underscore your table name, and the two non-clustered index, one for each foreign key column. So let us see this thing. So you can see this is my pk underscore address, and here it is saying it is a clustered index, and right, and then you can see ix, whatever your table name and whatever your foreign key column, this is going to be a unique non-clustered index. This is also unique and non-clustered index. Clear, guys?
Why one is unique, one is non-unique?
Sorry.
Why one is unique, one is non-unique? Student ID is unique, teacher ID is non-unique,
So why?
non-clustered.
Yeah. So that's what we need to identify. Address student ID, address teacher ID. Student ID is unique. Teacher ID is non-unique and non-clustered, right? So that why it is following this default convention. So now if you look at this address entity, it is referring to the teacher and it is also referring to the student. And now if you go to the teacher entity, this is represented as ID, and this is also represented as student ID. So ideally, it should be, right, what I can say, there should not be any, so both should be non-unique, right? Why it is creating unique?
Yeah,
Because the
right.
student, right, it considered as a unique. Actually, there should not be. Both are going to be only non-unique by default. So this is not unique, right? Why it is showing unique, I don't know. But ideally, it should be non-unique. Let me check the right create table statement. Let me open this one.
Check constantly, it has added.
Is this because of this? Okay, let me start this one more time. Ideally, it should not be right any right unique and a non-unique constant, right? So because right we are not applying any what I can say So course, teacher, students, that's fine. So teacher ID, student ID, both are optional. Teacher, student, that is fine. Teacher entity, this is my teacher entity, and this is my student entity. Why it is applying this filter and all these things? Okay, I'll come to this point, right? Why it is creating this as a unique constant, right? Ideally, it's not be unique, right? Why? Because, right, we are creating this column as a nullable type. Nullable type means they can accept null value. If they are accepting null value, it means they should not contain any, right? What I can say, they should not be right unique. They should be right non-unique, right? But why it is creating the student ID as a unique? That what I will come to. I will do some research about this and I will come back. Meanwhile, you also guys do some research, right? Why it is creating this teacher ID as a unique constant, even though we are accepting some duplicate values, right? Duplicate means integer nullable type. Nullable type means non-value is accepted, right? As non-value is accepted, then it should not contain any, right? What I can say means it should be non-unique. But why it is creating a unique? Uh, I will do some research and I'll come back to this point, right? Why it is creating this one. For now, just remember, right? So it is going to create some, right? What I can say, non-clustered index and based on the foreign key and for the primary key, it is going to create the clustered index, right? So I'll come to this point. Why it is creating this as a non-unique and why it is creating this, why it is creating this as non-unique and why it is creating as a unique clustered index, right? Meanwhile, you also got to do some research, right? Why it is creating something like this. Clear?
Yes, sir.
Right? So do some research why it is non-unique and why it is unique. That what it we need to understand. So, but now just remember, if it is a primary key, right, the index, primary key index means it is going to be always cluster index. The name is going to be pk underscore table name. Foreign key means it is going to be non-clustered index. The table name it is going to be right a foreign key column. Clear, guys?
Yes, sir.
Clear? So next one is null and not null columns, right? So guys, remember, entity from our core determines nullability based on the C sharp property types. Nullable, not non-nullable means if you are defining some property like integer, boolean, decimal, rectangle, they are going to be created as not null constants. If I'm defining nullable, that is whatever the data type, if I'm specifying this question mark, then they are going to be mapped to null columns. By default, string byte here, they are going to be considered as nullable type, even though, see, these are string byte here, they are reference type, but they are going to be considered as, right, treated as nullable, but explicit configuration you can also apply like required and all these things, which we will discuss, right? For now, you can right, ignore this thing, right? So, because I have not yet discussed, right, what is data annotations, what is required attribute, right? All these things we will discuss later. But for now, Any nullable type property means they are going to be created as null column. Non-nullable means not null, right? For example, in this student entity, you can see integer string. So I have not applied any constraint, right? I have not applied. Sorry, I'm not making these two properties as nullable type. But here you can see these two properties like last name and date of birth. I'm making them as a nullable type. So in the database, if you look at the student entity, these two columns will be created as a nullable type. So you can see last name and date of birth. These are nullable type. The rest of all the columns you can see they are not null. So the point that what you remember, so this is nullable and this is not, right? If I'm putting this question mark, I'm making this property as a nullable type. For nullable type property, it is going to create the database with null constant. If I'm using, right, if I'm not specifying this one, then it is going to be not null column. Clear?
In case of integer, decimal, and bool, why it is not showing the warning?
Sorry?
In case of decimal and bool, it is not showing the warning. Na? That is green color. It is not showing. Why?
See, why it is not showing? The reason is, so string is a reference type or value type.
Reference.
Reference type.
Reference.
The reference type means what? They can by default, the default value of this data type is
None.
right, what not. So that is the reason why, right, you are getting this warning. But this integer, date time, decimal, boolean, right? So these are value type or reference type.
Value type.
Value type.
Value type.
How you can say these are value type? By looking at what you can tell that this is a value type and this is a reference type. What should be
String class.
the string is going to be a class. If you go to the definition, it is a class. So if you are seeing this class keyword means what? Means it is a
Reference.
reference type.
Reference
So
type.
how you can make
Reference
sure
type.
that integer is a
It is a
value?
struct.
It is a
Struct.
Data type is going to be struct, right? So if you go to the definition, the data type is struct. Struct means it's a value type. So if it is a value type, it is not going to store the default value null by default. So that is the
Zero.
reason why it is not giving any warning. But it is a reference type means you can store some default value null. That is the reason why it is showing that warning that it can contain some null value. And coming to this byte array, you can see this is a struct, but in this case, this is one array. So array means it can contain non-null value, right? That is the reason why it is showing this one, right? But Boolean, decimal, date time, integer, these are purely value type. Right? So as value type, right, they are not going to store. But if you want, for example, you want to store a null value in the GPA, you can mark this question mark, no issue. So now it is going to be nullable type. Instead of not null, it is going to create a null column. Clear?
Yeah.
Yes, sir.
So this is the default and you can see. So default database column order. Guys, remember by default, right, on which order you are providing the column, right, you are providing the properties in the same order the database table is going to be, the database columns are going to be created. For example, student ID, first name, last name, date of birth, DPA is active, right? It is the same order, student ID, first name, last name, date of birth, GPA is active, profile picture, gender, right? The way we are providing the properties in the same order, the columns are going to be created, but here it is except the primary key column, except the primary key column means what? This primary key column is definitely going to be the first column in the database, and after that the rest of the columns are going to be stored. If you are putting the primary key column in the first position, that is well and fine, but if you coming to this address entity where I put the primary key column in the fourth position, but even though it is placed in the fourth position, if you look at the table, it is going to be in the first position, then rest of the column. Now if you look at the addresses entity, you can see address ID is the first column, then street, city, postal code, state, right? Then street, city, postal code, state, all these columns are going to be there. So the primary key column is the first column, and the rest of the column on whatever order you are putting, providing, in that order only it is going to be created. So can we change the default order? Yes, that is also possible. How? We need to see, right? We need to use something called data annotation attribute, and we will discuss that in our, right, either in the today's session or in the upcoming session. Clear?
Yes, sir.
Right? So column data types means what, right? So based on the data type mapping, means if I'm using C# data type, then what should be the SQL Server type? So integer will be integer, long will be big int, short equals to small int, byte equals to 10 int, boolean equals to bit, decimal, by default it is going to be decimal 18 comma 2, float real, double float. Right? So these are the default data types. If I'm using string, then by default it is going to be in worker max. If I'm using character, then this is going to be in worker of 1. Date time, by default, date time it is going to be date time 2, date time offset, time span, GOID, right? Unique identifier, byte array, right? So these are the default data type, right? These are our .NET data type. If I use this data type, then how the data type is going to be right created in the SQL Server is this one. For example, Boolean becomes a bit, right? So in the database, if you see, so is active. So in my application, I have provided this is active as Boolean, but in the database, it is created as bit. In my application, I specify DPA, GPA as decimal, and here it is going to be created as decimal, right? Where is GPA decimal 18 comma 2. Date of birth, you can see date time 2. So that is what we need to understand. Clear?
Yes, sir.
Right. So default cascade behavior, this is very, very important, right? Whenever you are maintaining the relationship, that is, there is a primary key table, or you can say primary entities, there is also dependent entities. And whenever we are creating the dependent entities, their existence is going to be checked in the primary key table. So that is fine. But what will happen if you are updating or deleting the primary key entities? How the related dependent entities are going to be managed? That is what is going to be defined with some default cascade behavior. So relationship required dependent means what? So whatever the foreign key column we created, is the foreign key is a nullable type or not now? So based on these things, right, it is going to decide the cascade behavior. If the foreign key is not null, then what exactly it is going to do? It is going to configure cascade delete behavior. If the foreign key is not null, it is going to configure the cascade delete behavior. So, sir, what do you mean by cascade delete behavior? Cascade delete behavior means if I'm deleting principal entity, automatically the dependent entities are going to be deleted. Cascade delete means if I'm deleting the principal entity, then automatically the deleted, right, the related entities are going to be deleted. Now, if you look at the teacher and the courses entity, so this is my right teacher entity. So here teacher ID, full name, work name, all this thing is there. Courses entity. Here I am creating this teacher ID. So this teacher ID in this case going to be created as a foreign key. So this foreign key, what it is creating, it is optional or required.
Required.
So if you look at the courses entity, if you look at the courses entity, then the foreign key it is creating as a not null column or nullable column, not null column.
Not null.
So
Not
if
null
the
column.
right, so if the relation is mandatory, if the relation is a required relation, then in that case, by default, what a entity framework core is going to do, it is going to set the delete behavior as a cascade delete. So you can also verify the same thing. How? Just right click on this one, script create to statement, right? So this will open the create SQL stable statement where it will show you what behavior they have implemented. And here you can see for this foreign key, they have implemented on delete cascade. So on delete cascade means what? Now, if I'm deleting the primary entity, that is the teacher entity in this case, when the related courses, what the teacher is teaching, they are going to be deleted. Clear? Automatically. You do not need to do anything special. They are going to be deleted automatically. Is that clear?
Okay.
Right? Yes or no?
Yes, sir.
Yes, sir.
Right.
Yes.
But what in the case if the right? What in the case if the relationship is optional? For example, if you look at the right, what I can say address entity. So in the address entity, teacher ID is a foreign key. This student ID is a foreign key. But these two are mandatory relationship or optional relationship?
Optional.
Optional.
Why? Because null level, they're accepting null value. So in the case of optional relationship, right, what they are going to do is they are going to set the delete behavior as no action. So what they are going to do, it will set the delete behavior as no action. So no action means what? No action means, right? So no action means, right, whatever the default behavior that is going to be set. Now, and guys, remember, no action means there is no specific cascade delete behavior is going to be set. Whatever the default behavior of the database, that will come into the picture. Now, if you look at this, then you will see there is no cascade delete behavior is configured. So you can see there is no cascade delete behavior is configured for this foreign key as well as for this foreign key. So if no cascade delete behavior is configured, that means by default it is going to take no action. No action means what? No action means whenever I'm deleting the primary key constant, the foreign key column is going to be stored with the default value, right? So default value means the foreign key column is going to store null value. So is this column accepting null value? Yes, this is accepting null value. So once the primary key entity is deleted, the related entity in the dependent entity, right, it is going to store null value. Automatically that column will be replaced with the null value, right? For example, if I delete one teacher, then that address in this entity, that teacher ID is going to be replaced with null value. Similarly, if I delete a student, that student ID, it is going to replaced with null value. This is the default behavior, but if you want, you can manage. Right? For even though if this is an optional relationship, if you want that no, even though it is a optional relationship, but if the primary entity is deleted, then also I need to delete the related entities from the dependent table. Then in that case, you can specify the right cascade delete behavior manually. That what you need to specify using Fluent API configurations. Clear, guys?
Yes, sir.
Right. So, and guys, remember, this is the fine for right optional and a relationship, or you can say mandatory relationship between one to one or one to many. But what about the right many to many relationship? So in the case of a many-to-many relationship, what will happen? Now it is not storing the data either in the principal entity or in the dependent entity. So in the case of a many-to-many relationship, both entities are going to be considered as a principal entity. So if I'm deleting a entity from the principal entity, then what will happen? The entity are going to be deleted from the joining table, because in the case of for many-to-many relationship, for example, course and student, we are having this course student entity. So this course entity, it is pointing to both the entities. If I am deleting a student from this table, then the related entity from this course student entity is going to be deleted, not from the courses table. If I'm deleting a course from this course entity, courses table, then the related entity from this course student table is going to be deleted, but not from the students table. Clear, guys? Yes or no?
Yes, sir.
This is the default behavior that what you need to understand. Is that clear?
Yes, sir.
Right. So default relationship we have already discussed many times. If both the right entities contain right reference navigation property and one of the entity contains the foreign key, then the relationship between them is one to one. If one of the entity contain reference navigation property and the other entity contain right collection navigation property, then the relationship between them is one to many, or you can say many to one. And if both the entities contain collection navigation property, then that relationship is said to be many to many relationship. To manage many to many relationship, entity framework core is going to generate a joining table. Clear? Clear or not?
Okay. Yes.
So in this case, between the student and course, you can see this is a collection property and this is a collection property. So the relationship is right many to many. And if you look at the student entity, this is the address, and in the address entity, this is student. So this is a one-to-one relationship. And in the student entity, right, you can see this is how the relationship is managed, right? So courses entity, list of student, teacher, right? So this is how you need to manage the relationship. If both entity containing the reference navigation property one to one. If one of the entity contain reference navigation property, other content collection navigation property, that is one to many, or you can say many to many, many to one. If both the entities containing collection navigation property, then that is going to be right what many to many. Clear, guys? So we have already discussed this relationship. Is that clear?
Yes, sir.
Right.
Yes.
So that is fine. Now what we need to understand the data annotation attributes, right? So we have discussed this default conventions, right? How entity framework manage the default, right, database schema based on the configuration. Now we need to proceed further and we need to see how we can overcome this default convention, or you can say how we can customize the database schema generation in entity framework core using data annotation. First of all, I will start with the data annotation, then I will discuss right about the Fluent API configurations, right? So this data annotation attributes, right, in entity framework core, they apply, right? These data annotation attributes are going to be applied, right, to the domain classes, or some of the attributes, right, they can also applicable to the properties of the domain classes to decide, right, to override the default convention what entity framework will follow. Right, so what entity framework default convention? If you want to override those default conventions, then the entity framework core provided us with a set of data annotations. So these data annotations are nothing but you can say classes, and they are inherited from the attribute class. And these classes we can apply right at the entity level, directly at the class level, as well as you can apply to the properties of the entities, right? So basically there are two major namespaces, right, provided for managing this. One is right system.component model data annotation, and one is for system.component model data annotation schema. So this schema is basically specifically for managing the right schema related attributes. This is for managing the validation and metadata. So what do you mean by schema related attribute? Let us try to understand. So schema related attribute means they impact how the database going to generate the schema. And for example, right, so guys remember whatever the right list I'm providing here, like table attribute, columns attribute, index attribute, all these attribute I'm going to discuss right in detail. Just have an overview. What are the schema related attributes Entity Framework Core provide? So table attribute means what? Right. So what is the default table name and what is the default schema? If you want to override, for example, I don't want to use the table with this name. I don't want to create a table with the student. I want to create a table with the student info. I don't want to create this table with a right DPO schema. I want to create this table with a admin schema, HR schema, sales schema. Then for that purpose, what you need to do, you need to make use of this table data annotation attribute. Using this attribute, you can specify what should be the table name, which should map to the following entity, and what should be the schema using which it is going to create it in the database. And right, this schema, this table name, it is the mandatory one. And this schema, whatever you are going to specify, this is optional. If you specify, it will make use this schema. If you don't specify, then what is the default schema DBO that will come into the picture. Clear? Right. So
Yeah.
if this
Yes.
is not clear, right, don't worry, we'll see this thing practically, right? Whatever I'm showing, every example I'm going to show you practically. Column attribute means, so using this column attribute, right, we are going to do three things. First of all, what is the default column name? The default column name is nothing but your property name. So whatever property name we specify, that is going to be my column name. Second thing is what is the default column order? On what order we provided, right? We place the property in the model, and in the same order, the columns are going to be created. And what is the default data type? I have provided the list. What is the default data type, right? So based on which the respective right column is going to be generated. If you want to modify these three things, I don't want to use the name. I want to provide a different column name which should map to the property name. I want to set a different column order. I want to use a different database data type rather than the default data type which is going to be generated based on the .NET data type. So if you want to overcome these three things, right, then what you need to do, you can make use of this column data annotation attribute. Clear?
Sir, this
Yes.
concept is clear, but why and what kind of cases, real-time scenarios, why
I'm
we
going to
should
discuss I'm going to, so currently what I'm showing, I'm only showing the syntax, right? What is the, how to use this thing and what is the purpose? What, under what scenario you need to
Yeah,
this one,
exactly.
you need to this one, right? That's what I'm going to discuss separately, right? You can see table attribute is there, key attribute is there, right? Foreign key attribute is there, right? Column attribute should be there, right? Right, column attribute is there. So respective chapter, I'm going to discuss, right, what is the real-time scenario. Clear?
Sir, will this order ID will applicable on primary key also? Will change?
What I have discussed.
You told
Primary
me
key is
that
always,
primary key will be
uh,
always first order.
so I'm going to discuss, right, what is the best
Okay,
scenario,
okay,
how to use the order, right? Practically, I'm going to show
okay,
you whether this applicable on the existing column or right existing table. If I'm applying order attribute on the existing table, then what I'm getting, why it should not, right? At what situation we need to apply, right? Whether it is makes sense to apply or not, right? All these
okay,
things,
okay,
do I need to apply this on all the properties? Everything I'm going to discuss, right? So but just for now, what is the objective of this column attribute? That's what I'm saying. Clear?
okay. Yes.
Everything, right? I'm going to discuss. Then the index attribute, right? So by default, as we have discussed, right? We can create a by default entity from our core is going to create a primary, right? Clustered index on the primary key, non-clustered index on the foreign key. Apart from this, right, any other column is there on which we want to apply some kind of indexes for faster data retrieval, then for that purpose, we need to make use of this index attribute. While I'm using this index attribute, it is going to create only non-clustered index. That index can be unique or non-unique. That's what we can specify. But using index attribute, we cannot create a clustered index. Only non-clustered, either unique or non-unique index we can create. Right? So for example, on the email property, I want to apply unique index. So I can use this index attribute, and there is a property called a unique, that value I need to set as a true. So that is what we need to do. Clear? Right. So foreign key attribute, see by default, you can see in this case, right, by default, if you look at this, teacher ID is going to be the foreign key. So instead of a teacher ID, if I want to create a different column, right, and if I want to mark that column as a foreign key, then for that purpose, what I need to do, I need to make use of this foreign key attribute. By default, the teacher ID column is there. But for example, right, so instead of this teacher ID, I want to make this as, right, by default, whatever it is fine, right? So TECH ID, I want to make this as the foreign key. By default, this is not the entity name plus ID, but I want to make. So what I need to do, I need to use this foreign key attribute and I need to specify, hey, this is going to be my foreign key, right? So that what I need to specify something like, so once I specify this, so now this is going to be the foreign key. Clear? But ideally, right, default one is more than sufficient. But yes, if you want to specify explicitly, that is fine, which will make your intention clear. The not mapped attribute means what, right? For example, you are having some column which is you required for calculating the logic at the application level, and you don't want those column, right? Or you can say those column on the database level. Then for that purpose, we can make use of this, right, not mapped attribute. So once I decorate any property with not mapped attribute, then this property, right, this property is not going to be created as a column in the database. Even we can also map this attribute directly at the entity level, for which we don't want to create any, right, database in the right, any table in the database. So what is the real time use case? So once I discuss this not map attribute, at that time I'm going to discuss. Now I'm just showing you the syntax. Clear? Right. So next one is inverse property. So inverse property means what? Now, for example, currently you can say this is fine. So this is take ID. And right, for the same teacher, right, if I want to create, right, multiple, right, for example, I want to create something called a take ID one, and I'm going to create, right, online teacher ID, right, online teacher ID. And also, right, I'm going to define offline teacher ID. So basically, right, what I can say, offline. So in this case, right, this is one foreign key, this is one foreign key, but the relation navigation property is same. Right. So if you want to handle such kind of relationship, right, when there is more than one relationship, automatically this is not going to be handled, right, by the framework. So for that purpose, what I need to do, we need to use inverse property, and we need to explicitly tell, right, which one, right, this foreign key is pointing to which, right, what I can say, inverse property. For example, in this case, I can make use of this one. So in this case, this is going to be a foreign key, this is going to be a foreign key, and it will work as expected, right? So that is what the use of inverse property. And what is the real-time use case? So by taking some real-time scenario, I'm going to discuss this inverse property. Database generated option means what, right? By default, right, in this case, you can see, if you look at the database column, you can see address column is generated as identity. Identity means automatically the column is going to be provided. Now, instead of this, right, if you want to make sure, no, I don't want to generate the primary key as a identity column, rather than some other property is there, which I want to mark as the identity column. Some of the property I want to dynamically generate the value, that is computed column. So for that purpose, what I need to do, I need to use this database generated. If the primary key, by default, it is going to be identity if it is an integer type. If you want to make sure that primary key is integer, but I don't want identity, then you have to use this one, identity dot non. Any other column for which you want to generate the value manually, you need to set identity. If you want to set the column value to be generated dynamically, you need to set this computed. And I will show you this thing practically, right? How to generate a non-primary key column value as identity, how to generate computed column value, what is the use of non, all these things we are going to discuss practically. Clear?
Can you please say the exact use of this inverse property? I didn't get that. What it is exactly means.
Sorry?
That
Sorry?
inverse property attribute. I didn't get that. What exactly mean on that?
So in this case, right? In this case, what I'm doing here, right? So I want to create this teacher ID. So in this case, offline teacher and online teacher ID. So both are going to be make as my foreign key, but both are going to be pointing to this teacher entity. By default, which one is going to be my foreign key? So that is what by default entity framework core is not going to manage if there is multiple foreign keys between two entities. So here one entity is course, one entity is teacher, but between this course and the teacher entity, I want to generate multiple foreign keys. So this is by default entity framework cannot handle. To handle such scenarios, we need to use this inverse property. How to use inverse property? By taking this scenario online example, online teacher, offline teacher, I'm going to explain that with one real-time scenario. But for now, just remember, if there is multiple relationship between two entities, then automatically that relationship is not identified by the entity framework core. In such situations, we need to make use of inverse property to explicitly tell this foreign key is related to this particular entity, this foreign key is related to this particular entity, right? Practically, right? While looking at this definition, if you are not understanding, don't worry, right? We should have one, right, a concept, right, inverse property. At that time, I'm going to discuss this, right, by taking, right, by explaining the concept with some real-time scenarios, right? So whatever I'm showing, every concept I'm going to discuss. If I'm, right, what error, right, by default, what error you are getting, how you can overcome this error using inverse property, everything I'm going to discuss. Clear?
Okay.
Now, so this database attribute, what we have discussed, right, this is related to schema. Schema means what? Means it is explicitly defining the database schema in the database. They are not going to provide any kind of a validation about the data. Now, whatever we are going to discuss, let us try to understand. So this key attribute, it is actually a attribute related to schema. This is present inside this system dot data component model dot data annotation, right? For example, right, by default, this is going to be my primary key. So instead of a course ID, so I want to generate something different, right? So some ID. Right? So I don't want ID and a course ID, rather than I want a different column, and I want this column to be the primary key. Then in that case, what I need to do, I need to decorate this column, right, with the key attribute. So once I decorate this is with the key attribute, right? So let me introduce this namespace. So then what will happen? Now this is going to be my primary key. By default, it is following ID plus entity name plus ID. But if there is no ID or entity name plus ID column, rather than you want to make some other column as the primary key column, then you need to make use of this key attribute. Clear? Clear, guys?
Yes.
Yes.
Required attribute means what, right? If you guys were working with a ASP.NET MVC or ASP.NET Web API application, then you might be knowing this required attribute. So this required attribute actually play two things, right? If you are using this entity framework model, right, entity framework code, then this required attribute will mark this as a not null column in the database. So this will make a column as not null, even though, for example, in the student entity, this is a question mark, but if I put the required attribute here, then this is going to be a right not null column in the. So this is going to be not null column in the database. And second thing, it is also going to do the client side and validation, right? Validation is whatever data you are receiving from the client. Uh, if you are using some validation like model state.isValid, right? Those who are having some experience into MVC and Web API, so they can what I can say recognize this concept, right? This is also going to do the validation. If you are creating one model, if that model column, right, for example, this last name property doesn't have any value, then it is going to give some kind of a error that this is a mandatory field. You cannot pass null value for this field, right? That is what we'll see this thing practically. So here it is going to make use of not null constant. And once we discuss the MVC and Web API application, at that time you will see how the validation is going to be handled using required attribute, right? So max length attribute is there, so which is going to set the maximum length of the column in the database. Max length 50 means it is going to create an marker of a 50 in the database. Similarly, this is also used for the validation purpose. Validation purpose means what? Means if you are sending a value which is greater than 50 character, it is going to give you error that the maximum 50 characters are allowed. Similarly, mean length, guys, remember the mean length doesn't have any impact on the database schema. It is only going to do the validation. That is what is the right minimum number of a character this field can accept. That validation you can implement, but this doesn't have any impact on the database schema, and it makes sense. Why? Because in database we can only set the maximum number of a character for a column. We cannot set the minimum number of a character. Similarly, string length attribute, this is the combination of a max length and the min length, right? Using a single attribute, we can specify what is the maximum length and what is the minimum length. What this attribute independently
दीदी
doing.
मैंने ना देखो सब कुछ वो मैं बैटर वगैरह सब बना दिया बस
This, this is very right irritating thing. You are unmuting yourself and you are talking with your family member, right? So this is my concurrence check attribute. So concurrence check attribute is basically comes into the picture, right? Whenever you are going to do some update and delete operations, right? To handle the concurrency in the right? If a multiple thread, right, trying to access the same data, trying to update or delete the same data, and if you don't want one of the update or delete override the previous operation, right? So concurrency control, you can say, then in that case you need to use this concurrency check. Again, guys, you will not understand this concurrency check attribute at this point of time. I will show you this thing practically, right? How the concurrency check handle the concurrency operation, right? In our application, I will show you practically. And the same thing is going to be done by this timestamp. Yes, so whatever this concurrency check is doing, the same thing is going to be done by this row version, or you can say timestamp. That is handling the concurrency control. So range attribute means what? This is the validation attribute, right? It means what? If you want to restrict that particular column value within some particular range, then you can make use of a range attribute, right? Similarly, there are some other, right, special attribute like which is used for validation purpose. For example, email address. For right, you want to have some property where you want to make sure that value is going to be a valid email address, that value is going to be valid phone number, that value is going to be valid credit card, that value is going to be valid URL, that value, right? For that purpose, we can make use of this special attribute. Even though this attribute is specified, But if you want, then you can also manually set the same thing, right? For example, I want to check a complex pattern that the password should contains 8 characters, some special character, some numeric character, right? So that customization, if you want, right, then you can make use of this regular expression attribute. And Fluent API versus data annotation, guys, remember, for simple configuration, for easy to understand configuration, Fluent API, sorry, data annotation is fine. But for more complication, more complex, right, complicated, right? For example, data shading, composite primary key, and global query filter, shadow properties, right? For them, right, more complex operation means we need to go with Fluent API, which we will discuss also in our coming session. And also, it is possible that we can combine both Fluent API and data annotations. And once we start developing the real-time application, at that time I'm going to discuss how we can combine both Fluent API and data annotation in a single project. So simple configuration we can achieve using data annotation. Complex configuration we need to do using Fluent API. Clear, guys?
Yeah. Sir, this data annotation is specific to entity framework only.
This data annotation, what I'm saying, it is specific to entity framework as well as for validation purpose.
Yeah, okay. So we can use this in web APIs as well, right?
Yes, in which web API you are creating entity, you need to decorate, right? Not
Okay.
all, right? So whatever the schema related, what I have specified, these are not related to validation. So other namespace, right? This namespace data annotation attribute,
Okay.
which we can apply, right? Required
Okay.
maximum minimum length, string length, right? So some of these are for right? See, this is not applicable for validation, right? Some of them are used for validation. Some of them are used for database schema. Some of them are used for both purposes, right? So as per your
Okay.
requirement, what is your objective, what you want to achieve, accordingly you need to decide what attribute I need to use, right?
Understood.
Yeah. Now, so in today's session, let us start as few data annotation attribute, at least, start with some data annotation attribute so that you will get more clarity. So table data annotation attribute, let us understand. So we have already discussed what is the default table name and default schema and how that is going to be generated by the entity framework code. So default is entity class name and the default is the deficit property name, right? Entity class name, if you are referring this as a reference property in other entity for which you are creating a table, then in that case also automatically it is going to use that entity class name as the table name. Otherwise, what you can do is you can specify the table name using the deficit property. Whatever the property name you specify, right, that is going to be created as a table. For example, if my deficit student is defined, right, deficit student is defined as student info, right? Suppose you define something like this, then in that case, students info is going to be your database table. So now, what is the use? The use of this table attribute is if you want to provide a custom table name. Custom table name means what, right? So whatever, see, guys, remember, table name, each company, they are having a standard table naming convention, right? So, and the entity name, we need to follow as per the industry standard. The table name that is going to be decided by the company. For example, I have seen, right, many existing database, they are starting the table with the TBL student, TBL employee, TBL product, TBL event, something like this, right? Some, right? So the point that what you need to remember, so TBL student is fine in the database. But do you think that it makes sense to create a entity with the name TBL student?
No, sir.
No.
No, sir.
That is second thing is that, right? For example, one existing database is there, which is already created. And using the database first approach, we created our entities. Once the entities are created, those entities are going to be created with the same name, whatever provided in the database. So do you think that whatever name they are providing, if that is not meaningful to you, then what you need to do? You need to provide a different entity name, right? But again, while providing a different entity name, you should also map that entity to that particular database table. Then situations like this, right? What we need to do? We need to go with the table data annotation attribute. Now, if you go to the definition of a table data annotation attribute, then you will see this table attribute, right, having the signature. Okay, so okay, let me go to the this one, right? Let me apply the table data annotation attribute, right? So now, if you go to the definition, then you will see this is. Okay, let me customize. So here, this table data annotation attribute, you can see it is having two, right? What I can say, properties, and you can see it is also having one constructor. Constructor means what? You can say this is the name attribute. So name attribute doesn't have the set accessor means what kind of a property is this? Read only property or read write property?
Read only.
Hashtag
Read only. Read
only
only.
property. So read-only property means you can only initialize that property using the constructor. So the table, so inside this table attribute class, you can see it is a class inherit from the attribute. This class taking one parameter, and that parameter you can use, right, to set this name property value. So within the constructor, what you need to do, it is mandatory to pass the name attribute. Optionally, you can pass the schema attribute. And if you are passing the schema attribute, that is going to be stored inside the schema property. Otherwise, what is the default schema that will come into the picture, right? So the point that what you need to remember. So this in this case, there are two properties. One is name and schema. Name is mandatory, which you need to pass to the constructor of the table attribute. Schema is optional. If you are passing, that will come into the picture. If you are not passing, then what is the default schema that will come into the picture? Clear?
Yes, sir.
Right. So let us understand this with one example. So what I'm doing here, I'm modifying the student entity altogether. So in this case, right, and second thing, what I'm going to do, and from this, right, I'm removing all these things, right? So currently you can see I'm specifying the property name as students, and okay, let me remove all other entities which are not required. And here I have specified the table name as student info. So guys, remember, if I'm specifying something using right, data annotation or Fluent API, then they will take precedence over the default convention. So as according to the default convention, it is should create the table with the students. But as we are applying the table attribute directly on the right, so this table attribute it can only be applied on the class level. So now it is going to create the table with the name student info, and that table is going to be mapped with the student entity. Clear? Clear or not?
Yes, sir.
Right. So let us write right. See, guys, remember these are the basic concept, and understanding this concept, right, is very very important, right? Without explaining this concept, right, I can start directly implementing the application, but understanding this is very very important, right? So now, right, what I'm doing, I'm generating the package manager console. Right now, tell me what should be the table name and what should be the schema.
Student info DBO.
Student info
Student
DBO.
So as per our understanding, it should be DBO and the table name is going to be student info. That is what it is creating. Clear?
Yes.
Yes or no?
Yes, sir.
Yes, sir.
Right. So how we can specify a different schema? So if you want to specify a different schema, right, then what you need to do, you can say this table attribute, right? There is a property called, it's inside this. Say you cannot set this name property. Why? Because it doesn't have any set accessor. But do you have any set accessor for this schema property? Yes or no?
Yes.
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 Yes, then what I can do is I can go to this one and I can the schema. Schema equals to whatever the schema you want to provide. Suppose I want to provide the schema as admin. So in this case, what I need to do, I need to use the schema admin. So with these changes right now, what I'm going to do, I'm going to generate, sorry, not this one. So package manager console, right? And again, generate the migration file. Give a different name and update the database. right? Now come to the database table and see whether this has changed the schema or not. What it is taking. So is the schema is changed to admin?
Yes.
Yes.
Yes. So now, so what is the limitation with this? Suppose I want to create all the tables with the schema admin, then all the tables I need to decorate it with the schema. But with the Fluent API, we can overcome this configuration. You can define the schema for all the table at a single location. That flexibility going to provide by Fluent API, which is not available with a data annotation attribute. So clear, guys? Is that clear?
Yeah.
Yes.
Yes.
Right. So
Yep.
when to use table attribute, if you want to provide some custom naming convention, when your database naming convention differs from your entity class naming convention, then the table attribute allows you to assign the right them with the name what you want to create in the database table, right? Without renaming your entity classes, right? For example, if your requirement is that I want to create the table with this syntax, EPL students, then that is possible, right? Using this one. So you will use this entity as student, but that is going to be created as a table student in the database, right? So basically, right, what I can say to customize the table names according to your database. That what you can make use of table attribute. Schema specification by default, if you don't want to use DPO, you want to use a different schema, then in that case, you need to use the table attribute and existing database. For example, for example, one table, suppose this table is created, right, based on the existing, right, you are using database first approach, and then this table is created based on the database. Now I cannot use this table student in my application, which doesn't make any sense. So what I can do is I can make this as a student, but again at that time I need to apply this table attribute which should map to the right table students table in the database. Clear?
Yes.
Yes or no? So
Yes,
these
sir.
are the right use cases of a table: custom naming convention, schema specification, and when you are working with the existing database, and if you want to right give a different name to your entities. So in that case, you can make use of table attribute. Clear? What is the real-time use cases? Is that clear?
Yes, sir.
Right. Next,
Yes, sir.
what I'm going to discuss, I'm going to discuss the column data annotation attribute, right? So this is the last thing what we are going to discuss in today's session. So by default, right, we have already discussed, right, coming before this one. So what is the default convention? By default, what is the column name entity framework is going to give? For example, student ID, first name and last name. So in this case, what should be the column name? The column name is going to be same as this property name or not?
Yes.
Yes.
What is the order? The column order, this is going to be first column, this is going to be second column, this is going to be third column. Yes or no?
Yes.
So,
And what is the default data type? So this is going to be integer, this is going to be marker of max, this is going to be marker of a max, right? So if you want to overcome this default convention, that is, you want to provide a different name than what the property name. If you want to specify the different data type rather than the default data type which entity framework is providing based on the .NET, and if you want to provide a different column order, and for example, primary key definitely it is going to the first column. I want this is the second column and this is the third column. Then if that is your requirement, then what you need to do, you need to make use of a column attribute. And this column attribute will provide us the flexibility to provide the column name, column type, and column order. So let us proceed and understand this thing, right? So if you look at the definition of this column data notation attribute, right? Here you can see, right? There are two constructor. One doesn't take any attribute parameter, right? One you can say default constructor, and one is taking the name. So if I'm using the first version of the attribute, what will happen? So what will happen means what is the default order that will come into the picture. So that means what? That means if default one will come into the picture, then it doesn't make any sense to use this column attribute anymore. So why I'm going to use this column attribute? If the default, if this constructor is going to take the default convention, then this first version is no longer not required at all, right? The second attribute what is provided, right? You can see first parameter is specifying the name. So what is the different name what you can provide? And the other things you can specify what is the default order. Default order is -1. -1 is means what? -1 means you don't consider the order into picture. Whatever the column order they are provided in the same order they are going to be created. No, I don't want that default order. I want to specify my own order. Then in that case, we need to make use of this order attribute. And type name means what is the data type you want to explicitly specify. For example, I want to explicitly specify the data type as envarchar of 50 instead of a default one is for string envarchar of maximum, right? So now if you look at this one, right, for example, right, this is my student info table. So in this case, what is the column size? Envarchar of max, envarchar of max. So no, I don't want max. I want maximum 50 character. I want maximum 30 character, right? So that is what possible using the type name attribute. Clear? Yes or no? Okay, let me show you this thing practically, right? So what I'm doing here, I'm modifying this one. So the table name is going to be student info, schema is going to be right admin. That is what I'm keeping as expected. And here you can see I'm applying this first name with a column. So in this case, what is the default right? What I can say, what is the default they will come into the picture. So what is the default name? What is the default order? And what is the default type? Those are will come into the picture, right? So and specifying this column attribute doesn't make any sense, right? If you specify, no issue, but doesn't make any sense. The second attribute, what I have specified here, right? You can see, if you go to the column attribute, the other overloaded version, right? This overloaded version, it is taking the string name. Okay, let me collapse to definition. So it is taking the string name. So whatever the name you want to provide for that particular property, that what you need to pass, right? So in this case, you can see I'm providing the L name. L name means what? This is going to be the column name, which is going to be created in the database, which is going to be mapped with the last name property. So, and in this case, you can see out of these three properties, this property can have only the get accessor. It doesn't have the set accessor. Means while creating the object, you have to provide the value into the constructor. So this is nothing but my constructor. That what I'm passing. Other order and type name, these are optional. And you can see these are having both a get and a set accessor. I will show you how to use the get and right order and right what is type name. But for now, if I generate the migration file and update the database, so it is going to create the admin student input table with the admin schema. This is going to be my primary key. And the first name, it is going to be this one by default, whatever we provided. And this column attribute, right, in this case, it is going to create the column with the name ln, right? So let me generate the migration file and show you this thing. So let me, right, generate migration 3. Right? Now let me refresh this table database. So let me refresh this table. So student ID, first name, and here you can see the L name it is created. So last name instead of last name, it is creating the column as L name. Why? Because of the right what I can say, this attribute, column attribute. Clear?
Yes, sir.
Right now. Now that is fine. So now what I need to do, I need to specify the column data type. So let me do some modification. So this is my column data type. So here you can see LN and here data type. Now what I need to do, this is LN, but also I want to specify the type. So type equals to type name equals to. So here I need to specify envarchar. So what is the SQL Server data type? Envarchar of right clear. And here you can see date of birth is my property name, but I want to create the column with the name DOP and the data type is going to be date time. So that is what I specify, right? So with these changes, what I can do is I can generate the right what I can say, migration file one more time. So migration 4, right? So, and here, right? So why I'm getting this error? An operation was called for it, that may be loss of data. Why this error? So, right? So in this case, why I'm getting this error? If you want to understand, right? Now tell me. Earlier, what is this column size?
10 worker of max.
50. Sorry, max. Now what I'm
Yes.
doing?
50.
Truncating.
I'm reducing the size or not?
Yes.
Yeah.
Yes, sir.
So if you are reducing the size, right, then you will get that you might be losing some data. Right? If I'm storing some value more than 50 characters, then at that time, right, it is going to make sure that you are going to lose some data. That is the reason why it is giving this warning, right? So please take care about this thing. So once this is done, right, I'm not going to get, okay. So what I'm saying, this, okay, so we need to update the migration, not the generate the migration, right? So migration file is applied. Now let me refresh the database, right? View the tables. And here you can see, right? So now it is n marker of 50. Now DOP date time 217, date time 2. That means it is working as expected. That means the column name and whatever the type, right, the type name we provided, they are working as expected. Yes or no?
Yes, sir.
Right. Now what I want to do is I want to specify the column order. Guys, remember there are few points that what you remember related to this order attribute, right? That is very, very important. Order means it is zero based order. It is zero based order, similar to your right array. Array index is always start from zero. So it is also going to start from zero. It is zero based order. Primary key should have the first column. Primary key should have the order number 0. Clear? It is zero based order. Primary key should have the order number 0. Third thing, order attribute should be applied to all the properties. Order attribute or order attribute should be applied to all properties. And it makes sense. For example, if there are 5 properties, if I'm applying this order, or you can say column attribute to the order, column attribute to the order property, right? So instead of order, we should say column order, right? Column attribute. So it is better to say column attribute with order property should be applied to all properties, and makes sense. Why? Because if I'm having one entity having 10 properties, if I apply this order to 5 properties, what about the other 5? How that other 5 is going to be rescheduled? So if you are applying the order of property of the column attribute, then it should be applied to all the properties, right? Then third one, it will come into the picture, it will come into the picture when you are creating the table. When you are creating the table, not modifying the table. Clear, guys? Not modifying the table. In this case, right, if you are modifying the table, you will get warning. So let us see whether we are following this thing. So I'm applying the column order 0, column order 2, column last name. So let me also provide that right type name attribute what we provided earlier. Right, what type name we provided. Okay. So type name equals to what data type we applied and marker of 50. And then this is going to my order 4. And here you can see this is primary key always going to be 0. Rest of the thing you can provide any order. So this is 2, this is order number 3, this is order number 5, 4, and this is going to be order number 1. So this will be the first column. Order number 1, this is going to be the second column. This is going to be the third column. this is going to be the fourth column, and this is going to be the last column, right? In that particular order, the columns are going to be stored. But the thing is that, right? We provided zero based order, yes. Primary key is starting with zero order, yes, that is primary key. It is starting with zero order. We are applying this order property of the column attribute to all the properties. You can see column with order, column with order. All the properties are assigned with the column and order attribute. The sequence doesn't matter. You can specify type first, then order. You can specify order first, then type. That doesn't matter, right? But what is? It will come into the picture only when you are creating the table, not modifying. Now, you just tell me, is the student info table already created in the database? Yes
Yes,
or
sir.
no?
Yes. Yes.
So if it is
Yes.
already created, then this order attribute doesn't have any impact on the column orders. Why? Because it is only come into the picture when creating the table, not modifying. So now we are modifying the table properties. We are not creating the student info table. The student info table is already created. Already created means this order attribute doesn't have any impact. And if you try to generate the migration, then you will get the warning. Let us see whether we are getting the warning or not. So let me generate one, right? And then update the database, right? So what I'm saying here, I'm getting some warning. The order of a column, last name was ignored. Column orders are only used when the table first created. And the same error message I'm getting for all the properties. Now, if you look at the My Student DB database, you will see all the columns, right? Whatever the new columns we have provided, those columns are going to be there, like mobile number and all these things, but they are going to be the same order, right? As the order in which they are, right, applied to this entry. Clear?
Okay.
If you use order, it means the ID cannot be auto-generated.
So ID
We,
auto cannot auto generated means what?
no, I mean, if you use the order, what happens to the order of the IDs there?
What IDs you are talking about?
I mean, the table's ID.
Sorry?
First. First only.
So what ID you are talking about?
The line 9.
Yeah, that
What
is
happens
student.
to the order if you change the order there? Because if it is auto-generated, you have table 1, table 2, table
What is
3,
the
table.
topic of auto generated? So that auto generated means that identity column. That is completely different altogether. So order attribute means the sequence of columns, right? That is going to be created in the database. What is there any relation between the auto generated identity column with this order attribute? Order property of the column attribute. Is there any
Fine.
relation?
No, that's fine. That's fine. I got it. That's fine. Got it.
Sir, I have one
Don't.
question.
Okay, let me first explain this, then I will take the question, right?
Okay.
So
No, I've got it.
currently you can say the order attribute is applied or not on the existing entity, on the existing database table. It is not applied, right? So now what I can do is to make sure, right, this order attribute is working, what you need to do, it should be a new. So while creating the order, right, while creating the database table for the first time, at that time, if you apply, they are going to be come into the picture. So what I can do is I can delete this database and regenerate the database. And at that time, you will see that order attribute will take effect, right? So I just delete and I just delete this migration folder. And then I just come and create the database, generate the migration. Okay, give one and update the database. So this time the order should come into the picture. Why? Because we are creating the table. So while creating the table, order will be come into the picture, but not while you are updating the table. So in this case, you can see the column, you can see student ID first, mobile second, first name third, DO before, LM is the last one. Why? Because in this case, right, LM, right, in this case, mobile is the last property in the sequence, but its order is one. One means after the zero, zero means the primary key. So after primary key, this is going to be the order, right? Student ID order. LM is the last one. Why? Because the order number is 4, right? So this is how it is coming picture. Clear, guys? Okay, now anybody having any question, they can ask.
Yes, sir. So suppose I am writing in the sequence like mobile after student ID I'm giving mobile, and then first name, last name, and DOB. So whatever sequence I am writing the properties, in the same sequence my table columns will be generated.
This is what I have already discussed.
Yeah,
Why you
right,
are
right. Yeah, then we can do the same thing now. Like anyhow, this has to be done during the table creation time, first time.
obviously,
So,
so that is the reason why my end solution is done, right? So
okay,
you should, right, when we apply the order property, right, it is only applicable while creating. But once the table is created, it doesn't have any impact. So you should
right.
avoid, right, using the order property. So it
Yeah,
doesn't make,
oh,
right? So
correct.
whatever your sequence, that what if you want to keep, please put them in the
Right.
same sequence order. That is fine. No need to use the
Yeah.
order attribute. And ideally, this order attribute is also not recommended, right? Because it
Mm,
doesn't make any sense.
okay. Same question I was asking.
Next question, please. If anybody having any.
Oh, yes, related to the schema. Actually, suppose we have suppose I have a two schema. One is admin and another is a client. Okay. I want to create a same table in both of the schema. Is it possible?
So why not? It is possible, right? Even I have not tried, but it should be possible, right? For example, right, table student info, right? So I have not tried this one, right? So let us try. But the thing is that, right? So what is the use of the same table with different schema?
Suppose in my project, I have created like a staging table. Suppose I have got to, any request from the client. Okay, we have some staging table with the max worker, everything data. Okay, and the main table schema is a DBO, and the staging table is a STG schema. Okay, the table name is same, but the how we can maintain this scenario in code first approach.
So that is what my question. Why you are creating, right, same table with a different schema?
I know.
Then for security reason, it's happening in my database also. They have a different schema for same table in
Yeah,
same database.
yeah, right. In my project also.
So then in that case, what you need to do, you can create a different entity, same properties, right? Even right, whatever it might be not related, right? So what you can do is, so student info, and this is going to be cell schema.
Probably it's for production,
In the
staging,
database, it is
that's
going to
testing.
right, student info table with cell schema, and then what you need to do, right? You need to use this one, my student.
Means in that scenario, we have to keep different class name, right?
So a different class name with, right, same properties and different schema.
I
In
think
this,
different schema comes from the maybe
now with this template,
production,
right? Now with this
production
template,
and that.
it should create the two tables. One is student info cells, right? Let me show you this thing practical, whether it is creating two different schema or not. My student require a primary key, right? So why exactly? So this is going to be my student. So if you want to make this as a primary key, so what you can do is you can apply the key attribute, which we are going to discuss.
Yeah.
So let me, okay. So this is not working, right? So whatever your query, right, I will come with some solution. This is not working. So if I'm giving the same table name, This is not working. The schema itself, the schema, okay, so same schema I have provided. That is the reason why. Let me give this as admin.
Mm-hmm.
So I have not tried this one, right? So let me give. Something you required or something different? This is what you required, right?
Yes. Got
Admin schema and this is sales schema. But I don't know whether this is the right approach or some better approach is there, right? I even don't know. Right? For now, that is what I can tell. Right? This is
But sir, in
GPS.
this case, I think two physical tables are there in database. Now that is not right actually.
That is what I'm asking now. Why you require two different data tables
Sir,
with a different schema?
because in our database, now there are so many different schemas for different roles. It's a role based. So they have a same table, same data, accessing with different schemas.
Exactly. That is the reason why I asked that question. Why you have two tables with the same schema? So what exactly in real time we do? We are creating. Suppose if my database having 20 tables, so 20 tables with the admin schema, 20 tables with DBA schema, 10 table with some different schema, right? And whenever I'm creating a user, what is the user role? Right, whether that user is accessible provided with the admin schema or DBA schema or all the schema, right? They can access those data. And whenever the user is logging, if that user is assigned with the admin schema only, then he can only view the admin related tables, cannot view other things, right? That is what we generally do in real-time project. I don't know why they are creating the same table with a different schema. What is the
Uh, uh,
actually use cases?
I
That
have
is
to
the reason
answer
why.
to one
Yes, yes.
person who said like staging table and data table, but staging and data table structure will be different.
Yes,
If
in
No.
staging
Yeah,
table,
we will
yes,
never
of course.
have the structure same for the staging and data table.
So my
No, what
question
I
is,
mean is,
the
if you have
structure is not
production,
same. The question is, if the structure is different, why you are giving the same? See,
it
ideally, what
doesn't
is
make
your
sense.
question, right? What the people who are doing this thing, right? What they are thinking, they are using the same table for the staging environment or the production environment. They are not using different database table. So that might be the scenario. But ideally, if the what is the meaning of a different structure for the staging and for the production? Right? So if someone doing this, you should ask the question, if I'm using staging in the staging environment and that is DBO in the production environment, then why the different structure?
No, sir, but in my application, they are using different schema, same table, same structure for security purpose.
Right? So that is what I'm saying now. What
Maybe
is
it's a
the
backup.
meaning?
Or maybe it's
Before
backup. I
the
don't know.
purpose
Yeah.
means
It
what?
has,
Right? So you just tell me same structure, same, right? So currently, right, what I'm doing, that is what you are doing in your company, right? The same structure, but different schema, right?
In
maybe
that
it's
case, na,
backup.
only one physical table in database, sir.
So
We are
how it is
accessing through different schema, but physically it's only one table.
So how it is that table is created with what schema? So whenever you are creating a table, that table is going to created with some schema. What is that schema?
So default schema is essay, but for user purpose, they are creating for a company domain name with table name.
Yes, so that is fine. So
I
in
think
this
that they
case,
are
instead of admin, right, I can create any schema, right? Then what you are talking, right? This is not creating different table, rather than they are creating different user with different access, role based,
Yes, exactly, like that, yes.
right?
I
Role
That
based.
think
is
that there will
tenacity. Maybe
I think that
tenacity.
there will be different type of users of database. So they are
Right?
using particular user for particular role. I think so.
Yes, sir,
That is what
something like this.
that,
And
that is
that's an
what we
authentication.
do. Because right, why am I going to create unnecessary same? Right? You just tell me, does it make sense to create a table with the same structure multiple times? Does it make sense?
No.
No.
So what we
I
need to
think maybe
generate
it's authorization, and yeah,
different
maybe
story.
authorization and
You can create a different user. You can give them access to different database. You can give them different access to different tables. You can give them access, right, to what they can perform, whether only select operation, read operation, write operation, right? So every possibility, right, the authentication, authorization, it's possible. We can validate them. But right, ideally, because why I'm saying, because same right, same table, same structure with different schema, I never right use in my right whole career. Yes, we are creating the table with different schema because right we want, because some HR team right, some it's a salesperson are there, right, and they want to verify the data in the database. And what we generally do is we are creating some tables with the sales schema, and those tables are going to be accessible by the salesperson only. Other admin related table, other schema related table, they don't have access. But that doesn't mean I'm going to create the same table for the salesperson separately, for the admin person separately, right? For the different person, right? User separately doesn't make any sense. But ideally, right, I might not be understanding what is your requirement in your company. That might be suggested that you should create, right, the same table with a different structure. But what is right the purpose, right? For example, whenever I'm doing some transaction, on which table I need to insert the data? Am I going to insert the same data on multiple tables? Right? So ideally, right, I'm not sure, right, why, right, you guys are creating, right, same table multiple times with a different schema, but ideally that should not be the scenario. Clear?
what I personally know is I think it comes with tenacity, but it's one schema, but with authorization and authentication. So different person can can check out the database in different ways, the tables, just like tenacity, which tenant